All right, it looks like it's working. So here we had to come up with a good scale on our x-axis and our y-axis. To label the points, we made sure whatever was listed first, that goes on our x-axis. Whatever's listed second goes on our y-axis. And did we do this one? Last class, example 5? No. Okay, so let's go back to example 5. Here's the graph of 4x minus 3. If you wanted to graph 4x minus 3, you could make a table of values. Can you see that when x is 0, you get minus 3? And that point is on that line. When you type in x is 1, 4 times 1 minus 3 would be 1, and that point is on the line. We're on the page before. We just hadn't done example 5 yet. So it says, find the value of the range when the value of the domain is 3. So they're saying if you put in an x value of 3, could you find the y value from the graph? Could you find the y value from the equation? So if I went to my graph, I go to an x value of 3, I go up, and I go, it looks like it's right there. What's the y value on the graph? What would be your best estimate?
8.5.
Well, careful, these are going by 2's.
Oh,
Is it? 9. That would be. Now let's check with the equation because that'll be more accurate. What is 4 times 3? Minus 3? It is 9. If we wanted to write this in function notation, this is what we just did. The function was g of x. We just figured out that g of 3 is 9. G of 3 is saying this is the y value when the x value is 3. Find the value of the domain when the value of the range is -7. So we are looking for this point. The range value is -7. According to the graph, what does the x value look like it should be? -1. Okay? If we did it in algebra, we would know that the y is -7. We would replace the g of x, because that's your y value, with -7. And we would have to solve, for x. So if you're solving an equation, go back to solving equations. What do you do with like terms? You want to put them together, but they're on opposite sides of the equation. So first, I'd have to add 3 and add 3. That would give me -4 equals 4x. And then to get x by itself, divide both sides by 4. -4 divided by 4. And you get -1. So the domain is -1. In function notation, that means that when we have a -1 for our x value, the y value is -7. Table values, we could add that point as well. Now for the whole graph, do you remember from Friday how we wrote the domain of a line that continued forever in this direction and ever in this direction?
The weird E.
The weird E.
R.
Or in interval notation, from -infinity to infinity. And the range would be the same thing, but now you're looking at your y values, right? Ranging.
or negative what?
Negative infinity to infinity.
I'm so lost.
So we're doing this example, right? They should probably. Okay. So you have your domain and ranges first assignment that I gave you. It's due tomorrow. For those of you that weren't here, I have extras. So who was not here?
Do you record all of like the lessons?
I do, except when the technology is crashing. Then sometimes it doesn't. Usually I have old videos online too. I just pass them on back to. Anybody else not have a domain and range assignment? Okay, turn to page 24. I'm going to hide my scale. In part B, I know it's kind of hard to read the graph. Create a scale that is appropriate for that graph on part B.
Did we put a line that this can be connected?
We'll just do the dots for now, and we'll talk about it.
Is that right though?
Whatever this would be on the bottom. That's H is on the bottom, and dose. All right. So, did you put the right thing, age, on the x-axis? I went up by 3s, because that matched up nicely. And then I went up by 15s. So we got 3, 15. 6, 25. If out there. 9, 45. 12, 45. 15, 65. 18, 65. And 21, 7. Now, as far as thinking about connecting this one, ages probably exist in between. Yes. But the dose might be like, it might come in full pills, right? Where a single pill is a certain amount. So sometimes you could maybe cut it up, and it is possible to get different milligrams, but sometimes it's not really easy. So there could be an argument that it is possible to connect these, and it isn't. Now, is this one a function?
Yeah.
Yes. Okay? It's okay that you have two y values the same. If you think about the vertical line test, if I take this vertical line and go across, do I ever hit more than one dot? No. So it is a function because of the vertical line test. Right? And if we wanted to do the domain that was given to us, the domain would be 3, 6, 9, 12, 18, 21, and then a range. So when you're just given points, you just list. We only have to write 45 once, we only have to write 65 once. So that's how we could do the domain and range. And for your very first assignment, that's due tomorrow, it is a lot about practicing and finding that domain and range. So we're going to do some more domain and range questions and look at some just different possibilities. So far we've done the possibilities where they're single points, and I showed you the possibility where it was everything. But now we're going to look at things that are sort of in between. Not single points, but not everything. And we're also going to look at the two different ways that you can write domain and range, in set notation and in interval notation. So, first of all, we're just going to start thinking about domain, remembering that domain is the x values. Can you tell me some x values that work? So here we have a graph, and that graph has a bunch of points. Could you tell me one point that's on the graph? Anywhere.
Or wait,
Like maybe you pick this one,
2 and 3.
or 2 and 3. Perfect. So since that point is 2, 3, can you see that 2 is a point in your domain, and 3 will be a point in your range? Okay? 3 and 8, yes, definitely. 3 will be a point in your domain, and 8 would be a point in your range. This is a 2. And here, we would have 0, -1. So 0 would be a point in your domain, and -1 would be a point in your range. So now I am going to give you a domain value, and you tell me if that point would be on the graph or not on the graph. So let's say I picked -2. Could you draw a point on the graph where the x value is -2? Yes or no?
Yes.
Yes, right? It'd be right there. What about 1.3? 1.3. Could you make an x value 1.3 and label that point on the graph?
Yes.
Yes. It wouldn't be easy to know exactly where it is, but 1.3 would be about there, right?
Yeah.
So that 1.3 is okay. What about 3.7?
No.
No.
Yeah.
Because 3.7 is past 3, and it wouldn't be on there. What about -8.3?
No.
Okay? Now something on our graph that's important to note. If a graph ends, they end it with a dot. Sometimes the dot will be filled in like this one. Sometimes the dot will be an open circle. So we're going to talk about the difference between a filled in dot and an open circle dot. But when a graph, the textbook, when a graph ends at the edge of the graph, they really should have put an arrowhead on the end. I'd like you to put an arrowhead on the end. That means that that graph goes up forever. It will also mean that it will go forever to the left. So can you see by putting this arrowhead on, like it's going to keep going up, but also keep going to the left forever. So when if I said -8.7, you'd be like, yes, there would be a point somewhere way up there where you would have -8.7. So when we go to write our domain, we have to come up with a rule. Now we're going to just start with the rule in words. Could you tell me a quick rule to explain which numbers are allowed in the domain?
The domain is
Does that make sense? He's saying that all the x values have to be less than or equal to 3.
Yep.
Yeah? So then how do we write that? Well, set notation is exactly how you said. We say that our x values have to be less than
The line at the bottom.
or equal to 3.
Does it work the other way as well, if we just flip it around like 3, and then,
We like to, yes, you could put the 3 first and the x second, but we like to put the x first. Okay? In interval notation, an interval is starting at the smallest value, going to the biggest value. So when we look at this graph, is there a smallest x value? Or does it just keep going to the left? It keeps going. So in interval notation, we would say, well, if it keeps going forever, we're going to start at negative infinity. And we're going to include everything until we get to
Infinity.
3,
Okay. Let's go.
right? Because at 3, it stops. And if a point is included, we use a square bracket. So a little note here, square bracket. The point is included. Next, this same one, we're going to do the range.
y is greater than or equal to -1.
Good.
Good.
Does that make sense what he said? The smallest y value that ever happens is -1. It doesn't stop at 8y because on this side, it goes up forever. So everything bigger than -1, there's a y value somewhere on that graph. So we say y is bigger than or equal to -1. In interval notation, does it have a smallest value? Yes, -1. Is -1 included? Yes. So we have a square bracket. Does it have a biggest value? No. So it goes up to infinity. Infinity always has a round bracket.
Wait, so what do you mean by that? Does it have a bigger value?
So when we're talking about our y values, if I told you, is there a point on this graph where the y value is 5? You would say yes, because I could go at 5, I could find one here, I could actually find 2 of them. What about 10? Ooh, it's not over here, but yes, over here there is a 10. So 10 is in my range. And the arrow means it goes up forever, so 50, you would go over, sure enough, there would be a point where it would touch. What about the decimals? Yes, you could do 7.1. I could go on here at 7.1, and I could find points where the y value is that. So we say in set notation, we would say, well, the range works for every single y value bigger than or equal to -1. Because -1 is the smallest one. If I said, is there a -2? You'd be like, no, it never hits the graph at -2. A y value of -2 wouldn't, there's no point on that graph that has a y value of -2. So we say the range is only the y values bigger than or equal to -1. I'm going to draw a line here. I'm going to do the second one in green. We're going to look at the set notation and the interval notation. But first of all, if we think about the domain, someone tell me an x value that for sure is in the domain.
-2.
-2, another one. Somebody else.
2.
2, perfect. Another one. Somebody else.
1.
1, perfect. Another x value that works.
Oh, wait, no.
3? Is
Oh,
there?
we're talking about the other one, my bad.
No.
1.5.
The other one also
1.5.
won't have it.
Okay.
1.3652.
So in words, could you say a rule for the x values that look like they're going to work? What would be like in words describing the x values that are on that graph?
Anything between negative 2 and 2.
Anything in between -2 and 2.
So it would be
So now we have to figure out,
x is greater than,
you correctly said it in words, how do mathematicians write that?
so it'd be -2, and then the right facing thing, yeah, and then, yeah, that one.
That's how we write x is in between -2 and 2.
What's the thing that's in between the x and positive
The same thing.
It said greater than or less than or equal to.
You know,
Yeah.
math, she's on.
I didn't see anything.
In interval notation, we start at our smallest value, which is -2, square bracket because it's included, and then go up to our biggest value, which is +2, and put it in square brackets.
Do we have, on the quizzes that we get, do we have to just show both add into it?
Maybe, like if a question asks, put your answer in interval notation, then you have to do it in that form. If it doesn't say, you get to choose. Okay? Now, on the green one, the second one, what about the range? Can you tell me a y value that works? Someone who hasn't said in one yet. A y value that works.
0.
0, another y value that works.
1.
1, good, another y value that works.
2.
2. Could you tell me a rule about the y values that work? In words.
Anywhere from 0 to 2.
Anything between 0 and 2. So how do we write that in set notation? We say 0 and 2. Now, if you read this, just how to read math, you can read this as 0 is less than or equal to y and less than or equal to 2. That's how you would read it from left to right. But you can also read this in parts.
Greater than or equal to 0.
Okay? If you read, if I read this part, I would say my y value, you can read inequalities backwards. So for those of you that like reading like Japanese anime comic books, how do they work? They start at the back of the book and you read it at the front of the book. But that's not the back of the book to them and the front of the book to them. It's just weird for us because we're used to it that way. Inequalities, you can read them both ways. You can say this as 0 is less than or equal to y, but you can read it backwards as well and say y has to be bigger than or equal to 0. Can you see your y values are for sure bigger than or equal to 0? And you can read it this part separately. Here, the y values also have to be less than or equal to 2. So if they have to be bigger than or equal to 0 and less than or equal to 2, does it make sense that y is now in between 0 and 2? In interval notation, we would write this as smallest value is 0, biggest value is 2, square brackets, because they're both included. Okay, I'm going to add a part C. You have space?
Oh,
Oh,
I got a little corner.
you got a little corner? Well,
Move on.
move on.
Uh-oh, another thing?
yeah, I'm gonna
Bro, don't do it.
try and stump you.
Don't do it.
I'm gonna introduce to you the open circle.
This thing called and what we do.
What?
We're doing negatives.
Right there, 0.
I'm gonna introduce to you the open circle.
Let's forget what the difference between a closed circle and an open circle is.
Let's figure out the domain of this one.
Oh, okay, yeah.
Can you tell me x values that work? 0 works, yeah. -1 works, perfect.
-3 does not work.
-3 does not work. That's the open circle means that it's close to -3. -2.99 works, but not -3.
So -2 works.
-2 works for sure. Yeah.
You would write it as.
-2 would be right here. That one works. Does 4 work?
Yes.
Yes, because this one is filled in 4 works.
So.
So it's anything in between -3 and 4, but it includes 4, but doesn't include -3.
So x is greater than 3, but less than or equal to 4.
It's been like 3 weeks.
You're saying
Are you okay with that? Interval, this is set notation. In interval notation, wow, spell today. We would go -3 is the smallest, 4 is the biggest, 4 is included,
but it's a.
-3 is not.
Oh yeah, 'cause
So interval just starts at the smallest one, says you include everything in between until you get to the biggest one. It would have a round bracket and a square bracket. In set notation, you would have a less than sign and a less than or equal sign. Range values. Tell me some range values, y values that work. 0 works, good. Does 5 work?
Yep.
What about 7?
No.
-4?
No.
No? -2?
Yep.
1.
No.
I heard some yeses, some no's.
Yes.
Okay?
Because it's on the
Final
right side
Because
as
it's
well.
also over here, right? That's a tricky one. It's not on the left side, but it is on the right side. So for our range, and you'll start to see this, when things are connected, we usually write the range as it's in between this and this. And you have to find the smallest range value and the biggest range value. Can you see that your smallest y value in this one is? -2. Is it included?
Yes.
So it has an equal sign. Then here's a y. And then what's your biggest y value? 5. Is it included?
And then have 2 square brackets, -2 and or 5.
Perfect. Now you guys are completely ready for your range assignment. But we've got a couple more examples. First of all, we're going to put an arrowhead on that side. So please add an arrowhead on that side in example 8.
No, we got it.
And again, we'll practice both set and interval notation. Now with the arrowhead on there, again, we could say x values that work. Can you see that -4 works? Can you see that 7 doesn't work? What about -1382.7? -1382.7, yes, because the arrowhead says it's going forever to the left and forever down. So, how do we write the domain for this one?
X is less than or equal to 5.
X is less than or equal to 5. Because it's not in between two things, because it goes on forever to the left. In interval notation, you always start with your smallest value. When there is no smallest value, you start at -infinity. Then you would go up to 5, round or square bracket?
Square.
Because it's included. The range for this one.
So wait, but hang on. Why
Yep.
would you put a round bracket on the negative
Yeah,
infinity?
isn't it
Because wouldn't
technically
it be
there?
included?
Well, your
Or it's not.
infinity's not a number, so you can't really include it, and it keeps on going. So that's they decided to make a round bracket.
Do it.
They're wrong.
Don't bother.
go on strike.
Do you want to learn how to do this in French immersion?
We put square bracket around that.
French immersion only uses square brackets, but sometimes they point in, sometimes they point out. So,
And that's why I love French.
this is French immersion for the same thing.
Yeah, I'm not complaining anymore, sorry.
Why?
I'm just gonna make my bracket.
Okay, what about the range? Is 3 in the range?
No.
What about -2?
Yes.
What about -4?
Yes.
Yeah.
Oh, I tried to trick you.
Why?
Didn't work. I went like this. What about -4? But it does exist over
I
on this
wasn't
side.
looking at this one.
So is there a smallest range value?
Why
No, it goes
less
down
than
forever.
or equal to 2?
Y has to be less than or equal to 2. And in interval notation, is there a smallest value? No. So we start at negative infinity. So the biggest value 2, it's included. Alright, part B. Domain. So as a strategy, when the thing is connected or the line is connected in between, do you see that your strategy is looking for a smallest value and a biggest value? Okay? Does this one have a smallest value for your x's?
-3.
-3. Right there. That's the smallest value for x's. Does it have a biggest value for x's? Yes, right there. +5. Can you see that your x values, everything in between there, exists? So we would write that x is between -3 and 5. There would be equal signs on both of them because the dots are filled in.
I don't understand how to do this set 1 5.
So the set one, you have to use greater than or equal signs. Like, we go back to the one that we just did. In words, can you see that every x value less than 5 would work? 5 works, 4 works, 3 works, 2.2 works, 2 works, 1.7 would work. Every number less than 5 works. So we have to use the less than or equal sign when we write.
So you find like the greatest common, or like the greatest number?
The greatest number that worked, and everything less than that was good. Because the arrow says you keep going forever to the left, and this one keeps going forever down. Right? Because if you just kept extending this line,
Oh, that's gone. You're gone. You're gone.
it would go on forever. I would have to keep going this way, and I'd have to keep going down. For the range of this one, is there a smallest y value?
Yeah.
What is it?
Oh wait, yeah. Oh yeah, 3.
3. Is there a biggest y value?
7.
7. So your y values have to be in between
Double square bracket.
3 and 7. And square brackets from 3 to 7. Okay, we got one more example, then I'll give you the last 10 minutes in class to work on your assignment.
Oh no, I put one.
Number of fishing boats anchored in an inlet. So at 9 o'clock in the morning, it looks like there was 25 boats sitting there. What's happening? What's happening right here? Why is there getting less? Looks like at 10, 11, 12.
Lunchtime.
Maybe they're going in for lunch. Well, are there any people that really like fishing in this class? Is it better to fish in the morning? The fish don't bite as much, so there's like, and then some people came back in the afternoon because they're just enjoying time on the lake.
Well, no, the sun goes down and then
I
it's
didn't
better
hear.
to catch fish.
There might be even more after that. Okay.
Where?
Which one's dependent? Which one's independent? One of these I have to say number of boats, one of them I have to say time.
Boats is independent. No.
Bro, you're tripping, bro.
Because you
Time
can
is
have.
time is
Oh, wait, yeah.
Time is independent.
Time is the X, it's the
Number of
independent.
boats is
What is
dependent.
wrong with it?
Yeah, that kind of bugs me too. Should we just?
Yeah, put
There we go.
independent at the top. I need
Yeah,
a razor.
come on.
There we go.
Get it.
Give me that razor. Don't mess with my business.
How about for lunch today?
Number of boats. Why are the points not connected?
Because they're not.
These are not fucking.
It is.
What would be the reason that you shouldn't connect the dots?
Because it's all over the place.
Well, that wouldn't be enough of an explanation.
You can't have 0.5 of a
It's
boat.
too much.
You can have 0.5 of a boat. You have half a
Are you
boat.
buying half a boat?
You're
What
screwed.
if your boat gets like cut in half or eaten by a shark?
Yeah, but then
You
it's
get
not gonna
half off
float. It's
Then,
at the bottom
then
of
you
the lake.
probably, if you look out there, it won't be anchored anymore. It'll be at the bottom, and you wouldn't count it.
It'll join the anchor.
I like this.
He doesn't want to run up to the W.
I like that explanation. Someone said you can't have half a boat. That describes it perfectly.
One,
Okay, this is the y. This is. Did someone think this was a fraction?
oh, yeah.
It's a y. U can't. It's not
Oh,
one
U.
over
What is
OU.
an equation?
Wait. So you only connect when you can have like.
You can only connect the things when it makes sense for both the x and the y.
Because like you can have 930.
So then, if you just have points, your domain is just writing the times. Can you see that our domain includes 10, 11, 12, 13, 14, 15, and the last one is 16. And the range, we have 6, 8, 10, 11, and 15. Is this a function? Oh, I missed one, didn't I? I missed this dot way up here at 9, which should be. Is this a function?
No.
Yes.
Oh, yeah.
It is a function. Because
Line method.
the vertical line, it's okay that there's two y values the same. But it would not be okay.
Okay, whatever.
We're done. Good job, guys.
We're good?
Yeah. Let's all.
Let's get them next time.